I'm going to use as another kind of experimental day. Yesterday I was looking at spec and Clojure tests and stuff like that, and I want to try to apply the little bits that I've learned there to some work that hopefully actually makes or actually applies a bit to what I want to accomplish with my rendering library here. And I'm just prepping my windows a little bit here, just trying to get things up and running. And I'll get right into it. So here we go. I've got here brainstorming. This is all I want to work on today. Brainstorming some effective data model ideas for 2D, 3D. I tried to do this before, and this is, for whatever reason, kind of a hard problem for me to wrap my head around. So there's always work to do. Eventually I'll get there, but I have to keep kind of trying, keep slicing away at the problem until I get something that I think could be a robust solution. Fun stuff that I've been reading about a lot and trying out here and there is functional representation and boundary representation, and parametric equations and stuff like that. So I want to see if maybe there's something useful I can do there. While I'm doing that, I want to see if I can use spec to kind of just use it in a with functions that I've created myself, and see if I can kind of build up a bit of a model from there. So that's the exercise for the day. Before I finalize that, I want to make sure that this will actually be doing what I want. So I have a let's pop what I'm working on down to the bottom of the spot here, and in fact cut that, because it's not an extension yet, into here. Okay, so today the section of what I'm working on is all in here. Let me do one of these. We got this. There we go. So parametric is the code set, like the set of functions that I want to mess around with and spec up if I can. And the document is just that is what gets rendered out into here. So for example, if I I don't want this like that. I want this. Yeah. So if I comment this out, comment this out, and comment this out, and change this for a moment, it should work. 2 times 10. So if I save that, I think I've set up my workflow okay, where this should turn into a 10. Or 20, I should say, which it does. So that's good. So let me just check in on this working okay. So far so good. Now if I do figure test area is the name. Draw, containers, figure, description, content. let's get something that I can draw in there right away. Rectangle. Is that gonna work? Yep, ish. So that's good. As a starting point, that'll be just fine. Let me get into that here. So if I do rectangle, so I do have a width, a height, and a color. Yeah. If I do polygon, points, rectangle, is this gonna work? Class, just familiarizing myself with this a little bit. Okay, that's wrong. Okay. So I have to fix that. Yeah. No problem. We do polygon. Zero, zero, 2, 0, 2, 2, 0, 2. That should be a square, but it should just be the outline, and I can go from there, I think. There we go. Okay. So that's a good that's good for testing purposes. So let's close up doc and let's have a look at parametric here. So I want to load in all of this stuff. Stylo.parametric. Oh, close off the namespace and get to work on a few little ideas here. So here I have these three functions here. They're frep, functional representation of solids, and they work by you pass in whatever parameters and return a function of x, y, and z, and then it will return to you a single value that is the distance that the point you give it is away from the surface of that shape itself. So the easy, or the simplest, one of the simplest ways to show this is to make a sphere. If I define A to be the function that's created when I make a sphere of radius 1. Now, if I pass a point, I'll get some floating point value out of it. I just have to pass it in the right form, which is like this. So -1. That means, or that is because the sphere itself is centered around the origin, and the point I checked with is the origin itself. And so since the sphere is radius 1 for a total diameter of 2, I'm at the origin, the distance that the point is from the edge of the sphere, from the shell of the sphere, is of course going to be -1. So that's just that's exactly what this function returns to you. It's a very simple x squared plus y squared plus z squared minus r squared equals 0, right? And then so you just, it equals 0 is the exact point that is on the sphere itself. So any non-zero value means the point you ask for is not along that plane. I'm hoping that makes any bit of sense. So what you can do, right, if we look at A again here and give it a point that we know is going to be on the sphere, for example 1, 0, 0, it's going to give us a value of 0, which is exactly what's provided there. So this is a very concise way to make spheres, and boxes and cylinders are those are the 3 example ones I've built up before. So comparing that idea with this parametric circle idea, right? A parametric circle, if I do def B is parametric circle given a radius of 1. What? Oh. There. Right, so now, so A is my sphere function, and B is a circle function where it's parametrized, it's different, right? I'm not giving it a point, I'm giving it a single value. So we can do 0, and it provides a point for me. And I can do B of 0.5, it'll give me a different point. Now, this is in 2 dimensions, first of all, and second of all, there's the floating point issues, where this is obviously supposed to be 0, right? It's so small that it should be 0 in theory, but it's going to give me a weird value there. So that's stuff to work on, but that's working pretty much as intended. So, there's one other thing I wanted to try, which was the idea of parametrizing a sphere itself. Now I looked up this a little earlier. This is the hemisphere, this is the surface, x squared plus y squared plus z squared equals a squared or r squared, such that z such that z is greater than or equal to 0. So it's the top half of a sphere basically, and you can parameterize this. It's a 3D surface. You can parameterize it down to 2 parameters, phi and theta, I think is what those are called. So I could actually make this function rather in a straightforward manner. It'll kind of look like this. So if I define a hemisphere function, parametric hemisphere, like that, and I give it a radius, I can return a function of u and v So I'm going to do a little trick here. Let u be times 2 math pi of u. Let's do it. UV is map that on UV. Right? So if I do that, it should, let me just double check that I'm making sense here. If I do that, parametric hemisphere of 1 since that's going to be a function, right? It's going to be a function expecting value between 0 and 1. So I do 1 and 1. Those are both correctly 2 pi, which is exactly what I want when I'm dealing with radians and stuff. So I should get approximate pi, yeah, for that. Okay. So that's just nicer. I don't know if it's actually ultimately a smart approach, but it's nice to be able to just do values between 0 and 1 instead of values between 0 and 2 pi. When I'm typing things in the REPL, it's pretty easy. So let's get back to this set of logic here for a moment. So just like the parametric circle takes a parameter and returns a 2D point, the parametric hemisphere is going to take 2 parameters and return a 3D point. So all I have to do is the equations for x, y, and z respectively, which is just these things here. Pretty straightforward. And then I believe that should work reasonably well. Then I'm going to turn towards thinking about how I can sort of discretize that in a nice way to draw into the space here. But I'll have to think about that because it might not be, well, I'll figure that out when the time comes. So x, we'll just do this. It's just all this stuff multiplied together. R math sine. Let's type it out properly here. Math sine u times math cos v yeah, and then y is almost the same, but it's sine, and then z is a cos, which is nice and simple, is times r math slash cosine u. So there we go. Then it's just a matter of returning the vector x, y, z. So now a parametric hemisphere, if I def C to be parametric hemisphere of radius 1, right? Now C, if I give it 0, 0, I should expect a value or a point from that. And what would I expect? Let me think for a moment. it would be 1x, 0y, 1z. Oh, 0, 0, 1. Oh, of course. The sine of u, which is 0 in this case, right, would be sine of 0 is 0, cos of 0 is 1, but 0 times anything is 0. Sine times sine, 0 times 0, cosine of 0 is 1. So the only value you get, z is 1. Nice. So then, now what do we have? We have, in general, consider different representations of geometric objects. We have frep, functional representation. It uses takes a point takes a coordinate x, y, z, for example, and returns a distance. But then we have brep, which is boundary representation. Where uses signed distance functions, SDF, takes coordinate and returns a distance. Sure, it's good enough for now. And the boundary representation uses parametric equations for edges and surfaces, which, so SDFs take a coordinate and return a distance. SDFs take a coordinate and return a distance. Yeah. So parametric equations for edges and surfaces. Parametric equations take parameters t, for example t, UV, take parameters and return a point. So those are like those are quite different, and I don't know the concise way to wire them together, right? But it seems useful to describe higher level things with both representations, right? So I just need to think through this for a moment. Okay, so let me go here to the idea of a sphere. Box and cylinder. Let me actually do this for a moment. Let me split it here. Sphere, box, cylinder. And I'll just move the boxes and cylinders out of the way for now, because I want to focus on spheres. So we do this. Okay, so I've got a sphere, circle, and a hemisphere. And I want to, let me merge all these code bits for a moment. Tangle that into there. Okay. That's something potentially useful. I have to borrow this too for a minute. If I go into here, do a rotate thing here, Clojure, tangle into param. Here I've got a rotate function, but all I want is, oh, this is not the right rotate. That won't be useful for me. I want this one. Oof, this is a little messy. I don't even remember what I did here. Shoot, that's not good. Refactor. Let me see here. Chunk. Refactor a few things. Unify the 2D, 3D functionality with the concept of sketches, which display in 2D by default. With the concepts of sketches and planes and projections, so that diagrams can be drawn easily and consistently. I also have to refactor the 3D rotation, rotation, translate, and scale can be reworked to work on a list of points, not on a map. And the third thing, the map data structure for 3D draw for renderable objects should be replanned, because it is too confusing. So what I want to maybe do there is consider using a tree structure similar to how Hiccup handles HTML nodes, HTML stuff. So I'll ignore the rotate for the time being, but I shall actually no, I'm not going to ignore rotate. I'm going to let me go here and let me figure it out for a moment. Here. Okay. Close that. Close that. Rotate. Rotate point. Scale theta. Let me just scale. What did I do here? What is this? Clearly, I'm in need of a little bit of a documentation catch-up in that one there. Right, so let me just run it to find out. Scale 90. It's not, I'm thinking it's scale, but it is not. It is, it's just, it returns math/sign of whatever and cos of whatever. So 1, 0, yeah. I don't know why I did that. Well, okay. That's a little weird that I decided to do that, but maybe I had a reason. Okay, well, so let me do rotate point of, let's give it a point 1, 1, 90. Yeah, it only works, it's a 2D point that's rotated about Z. That's what, oh, no, it's, okay, so, this would be cool. So what this is, you give it any 2 of 3 coordinates, and it'll rotate implicitly around the one that's not there. So if it's X and Y, it'll rotate around Z, the point. If it's this is poorly named because it's not rotating it. It's not like a real point anymore. It's ouch. Give the results of sine and cos of theta in degrees as like that. Confusing, but okay. So that's theoretically fine for now, for the time being. So this is so what this is doing, right, is so this isn't the right name, rotate point, because it's not rotating a point. It's just if the point were, it's actually should be more like it should be more like something like this. So you give it the point, and then you give it the yeah, this is mostly correct already. So this rotate point is what I'm going for, but I want it to be point axis theta like that. Rotate point helper. I need a better name for that, but it's not rotating a point. It's just like a you give it the xy, or you give it yz, or you give it whatever configuration of coordinates, and then it'll do the math for you. It'll return a 2D point because it's projecting it onto the 2D, kinda. Then point axis theta, I just need to do let xyz be point like that. Oops. Close that. But here, rotate point helper is going to be this function. Yeah, let's just do this first. Rotate point helper. And then this one is also rotate point helper. So that theoretically will work if I built these things properly. Okay. All right, so here we have rotate point. The point in this case, let's make it 1, 2, 3. Let's rotate it about Z by 90 degrees. Does that make sense? Since it's rotated about Z, Z shouldn't change. We moved it 90 degrees, so yeah, that does reasonably make sense. Y direction is 2, and then you rotate it, so then it's now -2 along X, and then X was 1. So now Y is going to be +1. Yep, that makes sense. So that seems to be working the way you would expect. So I kind of wonder, should I try an FDEF here just to flex that muscle a little bit here. SFDEF. Okay. So FDEF for rotate point. in this namespace needs args where I can do can even do the idea where I have sdef and what I have is let's do point, right, is, let me use here's an example schema from what I was looking at yesterday. Pardon me. So I have point is, it has to be a s/tuple containing number. Is that correct? We'll find out. Okay, so let's do s/valid for point, and we'll give it this is invalid, false, and that's true, and that's still true, and that's true. Perfect. So we have a point definition here, which is pretty nice. And then we could define axis, sdef axis, is going to be any s/star of x, y, or z. Is that, let's see if that makes sense. Oh, probably have to put that in a vector here, eh? So s_valid axis okay. Okay, so I did something wrong there. So axis, oh no, I'm using that a little bit wrong. Let's, if I just do def axes, I can make it x, y, z. Oh, wait a minute. Maybe I could just do this. Maybe I could directly do something like this. x, y, z. Let's try that now. Axis. There we go, that'll work. Y, Z. Any other key is false. Okay. Perfect. So that can be good. So we've got point, we've got an axis, and let's do let's leave that for now. I was gonna do maybe theta where I have to make it some amount of degrees, but I don't know, maybe I'll leave that alone for the time being. So now let's try FDef. Here is an example. Let's try it with rotate point. So the args okay, so there's args, return must be return is going to be int instead of int. It must be, let's go rotate point 1 2 3 axis x, rotate it 43. It returns a point, so return must be s valid point. I think that's okay to do it like that. And I'm pretty sure function is optional because there are no other restrictions. Yes, so let's see if that works. But first I have to actually fill in the args part here. Let's do s and s cat. We'll do point. Let me just check something here. Clojure spec guide. See, what I don't know is if I'm doing this part correctly. Predicates. So a registered spec can be used in place of a spec definition. Fully qualified. Okay, once a spec has been added to the registry, doc knows how to find it, that's good. Composing predicates, okay. Is this what I need? neighbor ID. Okay. S/or first case. Explain is fine. Entity maps. I'm not using multi-methods right now, so that doesn't matter too much for me at the moment. Collections. Oh, this is a side thought that just popped into my head. Let me see. It's not, wait, what? Veiled, valid. Okay. Okay. I wonder if I should do point 2D number and then point 3D S, well, at point 3D is this, and then point is S/def point S or point 2D point 3D. Does that work as a definition? Let's find out. Okay, so now S valid point, this should be invalid. This should be, it's not. Let me go back up here and find an OR. Oof. Need some water. Okay. I'm just misunderstanding how to compose these a little bit. Maybe it's just this S or 2D is that. I don't think this is right. Oh. True. False. So let me do S explain. Explain without a question mark. Okay, A and B. Oh, that's not what I needed. Okay, so well, that does work. I wonder maybe if return I can just make it like this. Pardon me. Okay, so let's go like this. S/cat point axis must be axis and theta must be a number I don't need the and either because there's no other conditions on it, I don't believe. So let's try that. So now okay, stest / instrument rotate point. Okay, now rotate point the way this is written, I'm only assuming 3D points anyway, so actually point here, before I even test this, I realize point has to be point 3D. it must be. Like there's no way that it'll work with 2 as written anyway. So now if I rotate point with a point that's empty, an axis that's wrong, and a theta that is right, execution error, invalid arguments. So s/explain that. Oh, it's the same, it doesn't make a difference. Okay. But then if I do rotate point where it's a valid point about x 90, sweet, it does work, which is good. Okay. And then there's one other thing, exercise. Okay. Oh, I don't have test check in here yet. Do I? Let's find out. Clojure.test. Oh, I do have test check, I think. Wait a minute, what am I doing? I got my depths right here, I could just look into it. Test check, I do have it, okay. Good, so I just kind of want to see spec gen alpha. Let's try that. Clojure.spec.gen alpha as gen. Okay. Will that load? Did I break it? What did I do? I messed something up here. Okay, there's that. There we go. Okay. Now, a generator. There are several ways to use it. You can generate a single sample value with generate, or a series of samples with samples. So some basic examples. Gen/generate sgen int. If I run it again and again, cool. Okay, so let me let's try one of my specs. Generate s/gen point. Cool. Will it generate a 3D point for me? Well, that's Is that a thing? Well, what? Clojure. Hmm. Okay. Hmm. Okay, well, let me put a little note here. See if it's going to be a problem in my spec defs for points. It probably will be. Let me see here. Okay. Let me just go back up to a generator for a minute and just cool. Okay, so seems to be working. The generator, that is. S exercise. Oh, did I did not redefine point, I guess? Yeah, okay. All right, so, oh. Oh boy. There's also exercise function, which creates sample arguments, invokes the function, and returns the arguments and the value. Let's see if exercise function works. Rotate point. Hey, it does. That's cool. Let's see this output for a minute. So the input was a point. The axis and the value. It's trying small values, but it technically is fine, right? Like it shouldn't matter. Wonder why it only is trying Hmm. 100 attempts to generate a value that passed the filter. Custom generator. Huh, neat. Okay, custom generators in order of preference. Let spec create a generator based on a predicate and spec, which is what I've done. Create your own from the tools, or use test check or other test check compatible libraries. Last option requires a runtime on test check, so the first two are strongly preferred. Consider a spec with a predicate to specify keywords from a particular name. Okay, well, I've got a spec function that seems to be working, which is a nice improvement over nothing. So now to move on from that a little bit, I can create here, rotate generically points axis theta, and in this case it's not anything but this here, map v partial rotate point axis theta, map v. Do I want to do, well, let's just do map. Partial, rotate point, I don't want a partial in this case. I actually want to do this. Rotate point, the axis, and theta, and you map it over the points. And that returns a bunch of rotated points. And then here, rotate about axis is what that should be, and then this should just be rotate Euler. I think that's what it is. Euler angles, I think that's what it is. Yeah. So I'll rotate about axis and rotate Euler. For the sake of this, that'll be okay. And it's just going to be points theta x, theta y, theta z. Thread first points into rotate about axis z, right? Points gets threaded in there, axis z, theta z. Yep, that's correct. Should be. Rotate about axis y, and this one rotate about axis x. So rotate Euler angles should now work. Def isometric Euler angles, which I have somewhere else too. Extensions, 3D. I forget where I put it. Euler here. There we go. 30, 45, 0. Okay. Let's see. Let's see if any of that works. Oop. Parametric. Rotate. Let's see what happens when I run these things. Def A is just a list of points. 0, 0, 0. 2, 0, 0. 2, 2, 0. And 0, 2, 0. So if I now rotate Euler A, isometric Euler angles, I do get a result, and they are 3D points. And so if I want to draw that as a polygon thought I had yeah, I can do points. Does that work? It does. Cool. Since it destructures the points, yeah, okay, sweet. So let me now try that for a moment. Here. And we'll do here, we'll do a polygon of what I had here, rotate, copy that, save that, let's see if that'll work. Appears that there's something wrong here. Polygon 2D unavailable in that context. Param CLJ. So I've got something, I'm calling something incorrectly somewhere in here. Parametric namespace is fine. Oh, maybe. Oh no, that should be okay. Box, cylinder should be fine, rotate should be totally fine, sphere, here, circle, this is where I have a problem. Let's do that. See if it builds. It does not. Could not load. Shoot, what have I messed up here? Oh, parametric. Let's see if that works. Unable to revolve symbol A in this context. Well, okay, that's weird, but that's a step in the right direction. Of course, here A is nothing. Foo. Zero 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 200 220 020. Foo, and draw foo for me. There we go. There, okay, so we've got rotations working, which is nice in the context of just lists of points, which is really nice. So now what I want to try is something. Let me see what would be cool. So we've got a parametric hemisphere C, right? Yeah. That returns points. So what would be cool is for U is range 0 to 1 in a step of 0.2, and V range 0 to 1 step 0.2 as well. Doing that, just do CUV. So that's a list of points. Let's try that. Hemisphere A is parametric hemisphere. Let's give it a radius of 1 is fine. Yeah. Then we'll define foo as this for thing here. So if I do for U range 0 to 1, step of 0.2, and V, same thing. So this is going to look weird. It won't be correct, right? Because it'll give me just a single list of points for a 3D shape. So it might look like a sort of spiral thing, I think, if I'm thinking about it correctly. We'll see in a minute if that makes any sense. Okay, let's try that. I wonder. C, of course, HSA. Always mixing up the symbol names a little bit. That is my bad. It doesn't look like anything. What else would be cool? I thought I had a draw annotations line arrow. I thought I had a dot function in here. I guess I don't. Maybe that is in Fabric. Let's pop that into an annotation. That is useful. Arrow or a dot there. Let's try that out. Let me see if I can draw a dot. stylo.draw/dot. Oops, it's not loaded. Annotations. Dot just takes an X and Y, so that's good. It'll look like, where'd it go? Dot. Let's do 10, 10. Let's try that, save that, and run it. And we'll have a look. Let's move it 1, 1 instead. Okay, so we have dots, and now let me just test this thing out. If I do apply dot, no, if I do this dot 1, 1, 9, will that still work? I think it will. Looks like it. So the dot should move to the right a little bit, or up a little bit, or down a little bit. Yeah, because it's X, this X positive goes left to right, Y positive goes top to bottom in SVG by default, unless I flip it around. Okay, so that does mean I should be able to map dot onto this and get kind of a weird looking, or maybe a cool looking situation going here. If I do a step of 05 though, make it a much bigger data thing, or give it many more points, I wonder what'll happen. A mess. A mess is what happens. Map plus map add this range of things. Yeah, 4 and repeat. Wait, is that going to work? Map plus onto, I don't think that's going to work. One, 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 one. Yeah, okay. I have to do this. Lambda add. Wait, am I doing this right? Map plus onto 1, 2, like that. And then this will be 3, 3, 0. That should work. Okay, So we've got a whole whack of dots. And let me, if I change the annotations, if I give the dots an outline as well, class is line and attention, and the radius, let's make it a little smaller. Yeah, save that. So one thing this doesn't show, like it doesn't show depth at all. Oof, what have I done? Why would it be like that? Oh, Oh, it'd be cool to have a little function that changes the color based on the Z value as well. So dot would give an XY position, then Z would be changed by the Z position it's on. So that's kind of neat. It's almost like you're drawing with particles or something. But even here with this setup, I can already see it's a hint at that does in fact look like a hemisphere, kinda, which is really cool. So in fact, another thing I could do, let me change this though for a moment to 500, 500, and the scale I want to make 10 instead. Will that work? Is that going to be the right thing? Oh, pardon me. Okay, the scale's smaller. Come on. I thought that I had added in here the that's not it. Oh, never mind. I know why. If I go and change a style definition here and add into the draw portion here into this list, if I do circle, save that. If I wait, the outlines should, once it rebuilds, well, it's still not right, or not what I expected, but let me now just fiddle with this, and we'll make the steps less frequent. It's very confusing, to me anyway. Okay, we're getting somewhere. So let me do even more steps, and we'll move this over even more. to get the hemisphere completely in here. Yes, okay. So that is very clearly a sphere, right? Which I'm pretty happy with so far. So that's really cool, but I do wonder right, so if I do well, let me pull out this here. Oh, I also just noticed it's not only a hemisphere, it's a full, because I didn't restrict negatives or anything, it's a proper sphere, right? So it's a full parametric sphere surface. Yeah. So dot sphere is actually going to be this. And even if I don't rotate it, not by this, but instead by 0, 0, 0, so the rotate its identity. I wonder if it'll just look like concentric circles or like lines, if it's on like lines of, oh, it actually looks like that. That's neat. So the next, oh, I haven't changed this, of course. That's why. Figure test area, draw for me a dot sphere. There we go. Okay. So that's like the top-down view of a globe, right? And if I were to rotate it about Y, let's do that just for fun. That looks cool. But I like the isometric because then you can tell like at a glance that it's a 3D thing. So I'm going to leave it like that. But I'm also going to define line sphere, and I'm going to do that by how does that work? Right, so foo is just a list of lines, or pardon me, a list of points. But what I actually need here is a new foo2, or bar, I guess is what people do now. Map plus 1, 2 onto a 4 thing where instead I've got u range 0 to 1 steps 0.1 and then another 4 inside there for, yeah, which should be a, yeah, this should, I think, be a different structure that I need, where it breaks the points out by layers instead. Let's see if that is a correct assumption. Oop. I just am changing the names just in case they end up clashing between my build and stuff like that. But I don't know. It's probably fine. Okay, now let's see. Bar Z. Wrong number of arguments passed to, oh shoot, I forgot. This here, repeat 10, 7, 0, just to translate all the points over. That's all that is. So this goes like that, and that's that. Did that work? Let's see. Yep. Delete that. Delete that. Come on. There. Now, okay, I'm doing something wrong here. Let's go C, right? 0, 1 is still, yeah, okay, we're good there. So if I do 4 U, range 0, 1, step 0.2, and then inside that another 4 V, range 0 to 1, 0.2. Now C UV, that does split things into, count this, right? Oop. 5. But if I do the for loop just as 1, like that, instead, count that. Yeah, okay, good. So, gotta answer a text first for a minute. right, back at the action. Okay, so the whole idea of checking this, the difference in the for, like the nested for structure here, is so that, oh, this, obviously this won't actually work anymore, of course. So let me modify that out of the way first. Yeah, so if I do this, get this out of the way, here I've got a list of lists, and the idea for the line sphere is for each for path in bar, you do polygon rotate. Right here, this is where I can do all the map magic and stuff like that. Polygon, where I do map plus 1, 2 over 4. Oh no, I don't need to do that. I actually, in this case, this is a little bit easier. Map. Nope. This. So path is a list of points. All I need to do is map path and repeat 10, 7, 0, right? Yep, that makes sense. Yeah. And I want to rotate this whole thing. No, I want to put the rotate inside first. There's definitely like a clean way to make this all more abstract, right? Like, I'm doing this weird map thing. I could just rewrite or write a translate function that goes on the outside of things, and that would obviously be better. But the purpose of what I'm doing today is to mess around with different representations of 3D models and different approaches for rendering them out on the screen, right? So it becomes I just had an idea, but I'm going to finish this little line of thinking first here. Rotate Euler path isometric Euler angles. Is that going to work? Is it going to render properly? Let me think about it. Or let's find out, I should say. Okay. Let's see if it works. Line sphere. So what I'm trying to do is make a path on a layer by layer basis. Instead of just putting dots at 3D points, yeah, there we go. It worked. So the cool thing there is I can independently, right, by changing the step values for each thing, I can change the resolutions independently, which is really cool. Right, so V happens to be the resolution of the circles themselves, right? And this is going to be the amount of paths that get placed on here, which is so cool, actually. And then actually let me now do bar 2, right, where it's just the inverse of these. So that should swap it all around. Line sphere is the, let me concatenate. Yeah, concatenate. Is that going to work now? We'll see. Yes, 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 yes. Okay, let's get the steps back in order here. Let's make this 1, and this is going to be 0.05 is still good for that. So what I just did there is I overlaid, you split it layer by layer horizontally, and you can also split it layer by layer vertical. Oh boy, let me 0.1, 0.05. Oosh, that looks weird. Right, so this, let's make that, let's do 0.05s all around, eh? How about that? 0.05s all around. There we go. That looks like a thing. So that is the power of a parametric surface. That's what that is. So if I change this to 8, right, that's the radius of this whole thing, so it should expand. Pretty straightforward. And so the actual 3D shape itself, right, is extremely concise. It's this line. It's just one line. And all of this stuff is just a unabstracted approach to drawing it on there, right? So like line sphere, and if I do dot sphere here, I can render them both over top of one another. Oh, if I move them both to the right spot. Also, let me change the style of the dots again. Annotation, dot. Let's just get rid of line, make it just a tension again, and we'll bring the size of this back up to 125, just a bit. Okay, so there's the set of dots. I just haven't moved them. let's go here. We've got rotate and split that off. And now we've got translate. So rotate works, you give it a list of points and the parameters it needs. So translate is easier. We can define translate. Oh, I can do another sdef here just for fun. Points. I think is just s any number of point. Right? No, but points has to be, well, first of all, let's see if this spec if it works. s/valid points, and then let's do for u range 0 to 1 of steps 0.1 and v, same thing, 0 to 1 steps of 0.1. Then I create a CUV. True. Okay. Good. Perfect. Okay. Translate is just going to take points and I want to do dx dy dt, but that sounds like a derivative. I'm going to do move x, move y, move z. Yeah, that's fine for now. That'll work. Right, so all you have to do map this function plus theta 1 or 1 2, map that function over the points and the repeat of mx, my, mz. That should work. So now we can try it here. Dot sphere is you rotate it, but I also want to translate this whole business by what was it, 10 7 0, and if the function is working, the dots should line up with that sphere when it rebuilds. If it's not working, I goofed. Okay, translate has an error. Persistent vector cannot be cast to number. Well, okay, let's go have a look here. What have I done? So, let me take this, def A. So A is a big list of points. Translate A by 111. Well, maybe I don't need to wrap it in this whole thing, right? Is that... yeah. Oh, I'm doing a silly. I could do something a little more like this. Right, so map add. Oh, it's I have to map add. So map the point onto, yeah, this is it, mx, my, mz. That should work now. Let's try that. There we go. Yes. That makes way more sense. Render area, let's have a look here. If I go there, it should just, once I save it, it should build, and I should get a nice translate going. Interesting. The reason that it did that is, I'm surprised. Okay, let me look through this for a moment. I'm gonna get rid of this bar 2 stuff just to keep things a little cleaner for the time being. So foo is that whole business for this. Bar is, I'm gonna make the same. Dot sphere, line sphere, let's get rid of the concatenate and just do that. For loop only. There's line sphere and there's dot sphere. Okay, so line sphere. I've got this weird map business going on here, which I don't want anymore. Instead, I want translate. I want to translate this by, I don't need to repeat this anymore. I just need that, translate. Okay, let's see. Let's see if that will work. The rebuild is obviously slow. That's something to work on in the future. Maybe it's errored out. Oh, I typoed something. Oh, foo. I also don't want to do that anymore. Let's get rid of the mapping here. Okay, foo is just a simple mapping, and bar is the slightly different mapping, but still the same, basically. Map dot onto this set of things, line sphere. For path in bar, do the polygon stuff. And the sphere, this should be good now. Let's try that. There we go. There we go. Okay, now we have things lined up. I had mistakenly translated a bunch of things a bunch of times, so don't need that anymore. So the other thought I had was so in a parametric sphere situation, right, a parametric first going to change the name. So here, both sphere and parametric sphere, they both take in the same parameter, just an R, and then you get, so it, right, if I were to do this, I could call supersphere takes R and it returns the function that you get when you have sphere R See, this is where I no longer know exactly how to split things up, right? So frep supersphere R, you get frep is what you get when you run what would you call this? Frep sphere, and this would technically be brep sphere, right? And then sphere itself would just be, before I forget this, brep sphere. A sphere would just be, you could do something like this. You have R, and then you make a map. Frep calls frep sphere. Do you even need a map? What happens if I just do this? Frep sphere. No. Frep sphere R. So you get a function there, and here rep is brep sphere, and you get a function there too. So if I build that all, and I do sphere def a sphere of 5. Oh, I forgot this. So A is a map of two functions. So if I do so how do I call that now? Oop, shoot, goofed it there. So if I were to do a frep, okay, that returns a function. So to call this, I have to wrap it one more time like this. A frep is, well, then I have to know, I need to know that I have to give it that. But it'd be way cooler if you got one function that would like properly dispatch to the sub functions based on the shape of the arguments. So actually, idea 1, sphere idea 2, same thing there with no, yeah. Okay, so sphere idea 2, you give it R, it'll build your functions out, but it returns a function that can take either, yeah, well, is that sensible? Let's find out. A function that is, if it's t, then you do, let's see if this makes any sense. A function of t, you do no, that's already incorrect. So the function is if you receive x, y, z, then you run the parametric circle, no, frep sphere. You do frep sphere. Let me make this just a little cleaner here. You do let frep be the function that you get when you run frep sphere r, right? Brep is brep sphere r. So those are given to you right there. If then you get a function that's xyz, it means you're running frep xyz, and you'll get an answer from that. Did I close? No, that's, let me fix this indentation. Here, if you get uv, you get brep uv. Let's see if this will work. If I could spell things right, it'd be a nice thing. So if I def a as sphere idea 2, radius 5, and then I call a with 1, 1, 1, I should get a distance. But if I call a with that I should get a point. Yeah, okay, so that does work. Is it wise to do that? I don't know. So that's nice for something like a sphere, but if I have a shape that's more and more complex, so this, by the way, might be, if I do def multi, no. So this idea is intriguing to me, that I just am not sure if this is really smart or really dangerous to do, right? That's a problem I'm having in my brain right now. What I like about this is you can build functions of shapes of whatever kind, 2D and 3D, I think. You can extrude, you can run an extrude on a boundary rep and get theoretically a nice boundary rep, and you can run an extrude on a 2D functional representation and get a 3D rep. I know that that's possible. So for any transform on any shape that you can nicely define with this, you can get nice results. But the things that become really challenging are things like union, intersections and stuff like that, because B-rep, it's pretty hard to do that stuff in. But it's pretty concise, right? That's the thing I like about it. Fairly concise. Okay, this is probably enough for today. Yeah, I am gonna call it a day for today. So so this parametric circle is B-rep circle, actually. It's parameterized on T. And then this circle thing here is actually unnecessary for the time being, but I have to move circle out into its own spot, because that would be better before I go. Circle, paste, there we go. Yeah, good enough for now. But sphere, let me make a few rough notes here for a minute. Following is an example of frep and brep functions for a sphere. I have some idea functions for tying both reps together into a single function for the potential challenges will arise with transforms, especially with Boolean CSG operations, i.e. union, difference, intersection, as they are quite easy with frep but quite difficult with brep. The breps for compound shapes could easily diverge in data structure from frep. For example, a box in brep might be defined by having a group of parameterized faces which need to be handled in some appropriate manner. The sphere is a bit simplistic because the brep and frep both map cleanly onto one another, but it's not. But it is not a guarantee that every shape you might want to draw, might want to build, has such properties. Okay, so I'm pretty happy with the fact that I've got a little bit of idea around maybe some different data structures for my drawings, and I'm also really happy with the fact that I was able to actually use in the rotate spot here some nice SDEFs and FDEF, use spec to verify and try some things out. So that hints at improving my workflow, which is really exciting because I can spec up all the different parts of this thing, right? I can spec up the draw so that it's formed nicely. I can spec up style if that makes sense. It might not, I don't know. And the builder too, where I've got a parser. It might be really important to spec that out. So I'm happy with the work today. It was really good. If you're tuned in live or later, thank you so much. I really appreciate that. For this month, I'm doing streams every day, although I might, in fact, have to change up that. I think on Friday, I won't be able to go anymore, so I'll miss the last weekend. Yeah. So I might be, well, I'll definitely be unable to do the last couple of days, but point is, I like doing this a lot and I'm going to keep it up even after the month is up. I'll have a more rigorous approach. I'll do fewer streams, but more prep, so that all the streams are more valuable and more exciting, both for me and for the watchers and listeners and viewers, whatever you want to call it. So stay tuned for that. I'm really excited, and I'm keen to keep getting better at both programming and streaming. So thanks for tuning in, and I will be back again tomorrow.